On to problem 1229 from the fundamentals of chapter 12 from New Dynamics. This problem's one of the trickier ones from this set of problems. I'll walk you through how I approached it. Right. It kind of utilizes a lot of the stuff you learn in the earlier problems, right? The kinematic equations and such. So some of the key things that you need to take away from this is they're telling you the car decelerates uniformly along the curved road. Okay, so it's very that's very important because it's telling us that our acceleration is going to be, our acceleration at, or actually our acceleration, the tangential acceleration at A is going to be equal to the tangential acceleration at B, which is the tangential acceleration at C. Okay, so the way I did this was, alright, so I have my velocity, or let's say my velocity at A is 25 meters per second. My velocity at B, I don't know that, and my velocity at C is 15 meters per second. And this is all given, so this is given, right? And then we're not given anything with accelerations other than that it's uniformly, right? So we need to look for an acceleration, and because we have some distance and a displacement between 2 points and a couple of velocities, my mind went straight to, okay, what's my final velocity, what's my initial velocity, and then plus some acceleration times your delta s, right? So this is what you have to fish out from your kinematic equations. Alright, so I said my final velocity is 15, my initial velocity is 25, plus 2 times this uniform constant deceleration, and then my displacement between those 2 points. Okay, and then when I do this, right? When I do this, I get AT is minus 0.667 meters per second squared. Okay, so you have to reorganize this and solve for AT. Okay, and now that I have this uniform acceleration, right, I kind of just said the same, or applied the same method as before, except instead of using, so here I was using, this was point C, this was point A, okay, I said, okay, what if I start from A and go to B, or start at B and go to C, alright, so you can say, okay, my final velocity at C is equal to my initial velocity at B, right? Which we don't know. But then we know the rest of these things. Plus 2 times minus 0.667. And what's the displacement between these two points, B and C? We know it's 50. Alright. So then, again, isolating everything, we're trying to isolate the velocity at B. Okay, so when we isolate, plug in the numbers, so let's plug in 15 here, right, because that's the velocity at the final point here. When we do this, we get V naught B, right, or let's just say VB, right, we get 17.1 meters per second. Okay, and you could have done it differently. You could have go from A to B, right? So initial velocity at A, final velocity at B. This is it's going to be up to you, okay? But just trust your math, trust your knowledge. All right. So we have the velocity at B. We have the tangential acceleration at B, because this is going to be A, B, and C. Okay, good. It's uniform. And now they give us the radius of curvature at point B, which is 300 meters. So that allows us to calculate the normal component of acceleration at B. It's going to be, what's my tangential velocity at B, right? And then what's my radius of curvature at B, right? We know what the velocity is going to be. We know it's 17.1 squared divided by 300. Okay? And then that should give us, so this will give us 0.975-ish meters per second squared. And then determine the acceleration of the car at B. So then to determine the full acceleration, it's pretty much telling us to get the magnitude. Right, it's going to be, it shows as negative, but it says it's squared. When you're taking the magnitude, I usually just write it as positive anyways, like that. It saves a split second, which is enough time to consider it as worth it. 0.667 squared plus 0.975 squared, so you have your normal acceleration squared plus tangential acceleration squared equals 1.18 meters per second squared. Okay, and then you're done. And then you have your acceleration at point B. Alright, so notice how this problem kind of made you look back into earlier problems, right, with these kinematic equations. That's why don't just try to memorize them and then just toss them to the side after you're done with that section of the book. You're gonna constantly be needing these sets of equations, so you gotta stash them away in a toolbox. Okay, you're gonna be constantly using them. Alright guys, thanks so much for your time. If you like this video, don't forget to subscribe and like. If you have comments, questions, concerns, just let me know in the comments. Thanks so much guys, have a good day.